Tonight's lesson is on our third law of exponents, raising a power to a power. We're going to complete a table similar to last night's and the one from the night before. I'm going to give you an expression, ask you to write it in expanded form, and then give it to me with using a single exponent. I'm going to complete one of the rows with you, and then I'm going to ask that you complete the other two rows on your own. So hopefully you have a pencil, you're ready to roll. Let's do the second row together. -2 to the third raised to the fourth power. Well, if we have it raised to the fourth power, it says whatever's here in parentheses, we multiply by itself 4 times. So we do -2 to the third times -2 to the third times -2 to the third times -2 to the third. Once we have it written in this form, we say, oh, we're multiplying. They have the same base. What do? We add the exponents. So that's -2 to the 3 plus 3 plus 3 plus 3. That's -2 to the 3 plus 3 is 6, plus 3 more is 9, plus 3 more is 12. So as a single exponent, this would be -2 to the 12th power. And what we're going to be trying to figure out, is there a more efficient way that we can go about raising a power, -2 to the third, to a power, to the fourth power? Or do we have to write out every time our multiplications? We'll check it out and we'll see. What I need you to do is try the first and third row. Pause the video, try it out, come on back. All right, hopefully you paused the video. For our first row, 5 squared to the third power, it means we're going to multiply 5 squared by itself 3 times. 5 squared times 5 squared times 5 squared. 2 plus 2 is 4, plus 2 is 6. So that's 5 to the 6th power. In the third row, x to the 4th squared means x to the 4th times x to the 4th. It means we'll have 2 factors of x to the 4th. Same base, you keep the base and you add the exponents when you're multiplying, so that becomes x to the 8th. And what we now need to look at is there a more efficient way when we raise a power to a power, as opposed to every time having to write out expanded form? So in order to figure out the more efficient way, you say to yourself, okay, for the first one, I kept the base of 5. What did I possibly do with my exponents, my 2 and my 3, to get to 6? What can you do with 2 and 3 to get to 6? Oh, 2 times 3 is 6. I wonder if that happens for others. So for the last one, x to the 4th raised to the 2nd power, I kept my base of x. And let's see, what can I do with 4 and 2, those powers, to get to 8? Well, 4 times 2 is 8. Does it work for the one here in the middle? My base here of -2, I kept my base of -2, and sure enough, what's 3 times 4? 3 times 4 is 12. So that's -2 to the 3 times 4. So a more efficient way to go about it, if you're raising a power to a power, you simply multiply the exponents, keep your base. So instead of writing out an expanded form every time we want to raise a power to a power when working with expressions involving exponents, what will we do? Power to a power. For example, 5 to the 2nd power, all raised to the 3rd power. We will keep the base and multiply your exponents. So we'll keep the base of 5, we'll multiply our exponents, 2 times 3, to get to 6. So that's just a more efficient way to go about power to a power. Can you write out an expanded form every time? Absolutely. Or you can just go ahead and multiply those exponents. For instance, this just restates what we figured out in the table. How to expand a power to a power. 2 to the 3rd, all raised to the 4th power, means 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. We know if we're multiplying to the 3rd by itself 4 times, that's 2 to the 3 plus 3 plus 3 plus 3. When you're multiplying, you just keep the base, add the exponents. That gets us 2 to the 12th. What's a quicker way to get to 2 to the 12th? Just do 2 to the 3 times 4 is 12. What I'd like you to do is take a minute, pause the video, then rewrite each of these expressions using a single exponent. So go ahead, pause the video, try them out, and then come on back. All right, hopefully you paused the video. One thing you may have chosen to do is you may have chosen to do s to the 17th times s to the 17th times s to the 17th times s to the 17th, which would be, we would just keep our s. 17 and 17 is 34. 34 and 17 is that 51, and 17 more is 68. I could have just added up all those 17s. Another way to go about it, s to the 17th, all raised to the 4th power, would be s to the 17 times 4. And guess what that is? S to the 17 times 4 happens to be 68. Use a calculator if you need. Second one, negative 2 to the 5th, all raised to the 8th power. You could write out negative 2 to the 5th times negative 2 to the 5th times negative 2 to the 5th 8 times. And then you could have said to yourself, oh goodness, well that's negative 2 to the 5 plus 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 5. Let me make sure I did it 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And that would be negative 2 to the 5, 10, 15, 20, 25, 30, 35. That would be negative 2 to the 40th power. So if I write it out in expanded form, multiplying negative 2 to the 5th by itself 8 times, I can totally do that, and I'll get negative 2 to the 40th. What's a quicker way to go about that? Keeping my negative 2 in parentheses. If I'm raising a power to a power, I simply multiply those exponents, 5 times 8. And that's negative 2, still in parentheses. 5 times 8 is 40. You have to decide what is better for you. Is it better for you to write out all of the factors and then add the exponents when you multiply? Absolutely, go ahead. Or if you're raising a power to a power, just to recall, oh, I simply need to multiply my exponents. Sarah wrote that 3 to the 5th to the 7th power was 3 to the 12th. You need to correct her mistake. First of all, explain what she did wrong. Then you're going to write an exponential expression using a base of 3 and the exponents 5, 7, and 12 that would make her answer correct. So take a minute, pause the video, try it out, come on back. All right, hopefully you paused the video. So the first thing we need to do is say what she did wrong. Okay, Sarah added the exponents when she should have multiplied them. Because we know 3 to the 5th to the 7th power should be 3 to the 5 times 7, or 3 to the 35th. She accidentally added her exponents. 5 plus 7 is 12. Second part says, try to write up an exponential expression using a base of 3 and the exponents of 5 and 7 that would make her answer correct, her 3 to the 12th. Well, 5 plus 7 is 12. That means if the expression given had been 3 to the 5th times 3 to the 7th, then she would have been fine, and that is 3 to the 12th. But when you're raising to a power, you certainly do not add the exponents, you multiply them. Next up, I need you to show or prove in detail why 2 times 3 times 4 raised to the 4th power is actually 2 to the 4th, 3 to the 4th, 4 to the 4th. So take a minute, pause the video, try it out, come on back. All right, hopefully you paused the video. 2 times 3 times 4 all to the 4th power. We know that that means 2 times 3 times 4 times 2 times 3 times 4 times 2 times 3 times 4 times 2 times 3 times 4. Just take whatever you're given within parentheses and multiply it by itself 4 times. Wow. Now I'm just going to go ahead and say how many factors of 2 do I have. I'm going to go ahead and group those together. 2 times 2 times 2 times 2. I have 4 factors of 2. Now I'm going to group all of my factors of 3 together. It appears to be 3 times 3 times 3 times 3. Ooh, now I'm going to group all of my factors of 4 together. 4 times 4 times 4 times 4. What's 2 times 2 times 2 times 2? Well, if I multiply 2 by itself 4 times, that means I have 2 to the 4th power. 3 times 3 times 3 times 3. If I multiply 3 by itself 4 times, that means I have 3 to the 4th power. And again, 4 times 4 times 4 times 4. If I have 4 factors of 4, I'm multiplying 4 by itself 4 times. That means my base is 4, my exponent is 4. We've just proved why 2 times 3 times 4 all raised to the 4th power becomes 2 to the 4th, 3 to the 4th, 4 to the 4th. If you don't see an exponent, you can always assume it's 1. And you'll see here, 2 to the 1 times 4 is 4. 3 to the 1 times 4 is 4. 4 to the 1 times 4 is 4. If you're raising to a power, you can simply multiply those exponents. We're going to talk more about that tomorrow. Finally, your reflection questions for tonight that I need you to write up and be ready to share tomorrow. First up, in your own words, describe the third law of exponents. That should say third, not second. The third law of exponents, raising a power to a power. So I just want to know, when you see raising a power to a power, in your own mind, what do you need to do? You can give examples to back it up if you'd like. Then I need you to simplify each of the following to a single exponent and explain how you obtained your answer. Take 2 to the 4th times 2 to the 3rd. Tell me what the answer would be and how you found that answer. 2 to the 4th divided by 2 to the 3rd. Tell me the answer and how you got that answer. And then 2 to the 4th all raised to the 3rd power. Tell me the answer and how you got the answer. I just need to make sure that you're getting clear in your mind our various laws of exponents and how we apply them. Try to have a good night. Thanks.